Hi, I'm Michelle Shkladok, and today I'm going to be teaching you about trends in size. So let's get started. Alright, so the first thing you have to know is about shielding. Shielding describes the decrease in attraction between an electron and the nucleus in any atom with more than one electron shell. So for example, if you look at carbon on the periodic table, you see that it has a nucleus charge of +6. Before it goes to the outer shell, it gets cancelled or shielded by the 2 electrons in the first energy level. And because of that, that weakens the attractive force by 2, so the outer level feels a charge of +4. So this might not make sense for now, but hopefully it will be as we go further through the PowerPoint. Alright, so let's get through some critical thinking questions. So number 1, how large is the charge that the second energy level of nitrogen feels from the nucleus? So nitrogen has a +7 charge. If you look at the periodic table, you can find that out. So the second energy level feels a charge of +5 from the nucleus. The total charge of the +7 gets weakened by the 2 electrons in the first level. So this is like the same thing as our example from the previous slide with carbon, except this time instead of a +6 charge, you have a +7 charge. So number 2, why does the first energy level in each of the 3 diagrams only contain 2 electrons? So this is because the first energy level cannot hold more than 2 electrons. So as you know, the first energy level can only hold 2 electrons, but the further you go along, the more they can hold. So number 3, how many electrons can fit in the second energy level? So in the second energy level, you can hold 6, but you also are adding the 2 electrons in the first energy level, so that makes a total of 8. So a total of 8 comes from the two electrons in the first energy level and the 6 electrons in the second energy level. Number 4, how many electrons can fit in the third energy level? Okay, so 18 can fit in the third energy level. This is because you fit 2 from the first energy level, 8 in the second energy level, and 8 in the third energy level. So continued with our critical thinking, number 5 says how many energy levels does aluminum have? How many should be in each energy level? So as you can see, aluminum has a +13 charge, which gets weakened by 2 electrons in the first energy level. The second energy level can hold 8, so there's 3 electrons left over for the third energy level. So let's look at the diagram. Okay, so this is the Bohr diagram for aluminum, which also goes into question 6, which says to draw a Bohr diagram for aluminum similar to above. So as we know, aluminum has a +13 charge. So it should have 3 energy levels and look similar to this. Okay, so as I said before, the first energy level can only hold 2 electrons. The second energy level can hold up to 8 electrons, and same with the third. But since aluminum has only a charge of 13, you're gonna need you put 2 electrons in the first level, which leaves you with a +11 charge, and then you have 8 in the second outer level. So that has a total of +10, and then you have 3 left over, so you have just 3 in the third energy level. So this is why there's 3 electrons left over for the third energy level. So hopefully that makes a little bit of sense. So let's continue. So number 7, explain why the second energy level of aluminum only feels a +11 attraction instead of a +13 attraction from aluminum's electrons. So, as we said before, it feels a +11 charge because the +13 charge gets weakened by the 2 electrons in the first energy level. So remember, the first energy level can only hold 2, and that's very different from the other outer levels because those can hold 8, but the first one can only hold 2, and that's very crucial that you remember that. So let's continue with number 8. How large is the charge that the third level of an aluminum atom feels from the nucleus? So it feels a +3 charge. The +13 charge of a nucleus gets weakened by the 2 electrons in the first energy level and then 8 in the second energy level. So then you have leftover of +3. And so I'm running out of time, so we will continue this in the next presentation.